Hello everybody, welcome back to Teach Me to Science, and today we're going to be defining rate laws. We're also going to be doing a couple of practice problems where we determine the rate law as well as the rate constant. This is how a typical rate law looks, and it gives you a lot of information. The exponents x and y are reaction orders. X describes the reaction order of A, while Y describes the reaction order of B. Rate laws are very beneficial as they show us how each component impacts the rate. The value K is the rate constant, and recall that a rate is a change in concentration over a change in time. It's also important to remember that there are several different types of reaction order. There's a zero order, a first order, and a second order reaction order. If you're a little bit rusty on reaction orders, please check out my video about them. I'll link it above. So now let's practice writing an actual rate law. Pause the video and give this a try. Alright, this paragraph over here has lots of useful information. It says that H2 is first order and F2 is also first order. So when we write our rate expression, we'll include K and know that both the concentration of H2 and the concentration of F2 are raised to the first power. It's important to know that the reaction orders are additive. Therefore, if the reaction order is first with respect to H2 and F2, that means 1 plus 1 is 2, and the overall reaction order is second order. Alright, let's bump it up a notch. Pause the video and try and solve this problem. So the first thing we're going to have to figure out is the reaction orders with respect to H2 and F2. And we have to do this using the experimental data. To do this, we need to find two trials where one of the concentrations is held constant and the other one is not. So here we see that F2 changes by a factor of 2, and the rate also changes by a factor of 2, which means the reaction is first order with respect to F2. Now we need to figure out the reaction order with respect to H2. So I'm picking two trials here where F2 concentration is held constant. And here I can see that the H2 concentration is multiplied by 4 and the rate also increases by 4. This means that the reaction order with respect to H2 is first order. It's very important that you hold one of the concentrations constant so that you know the change in rate you're observing is solely due to the change in concentration of the individual species that isn't being held constant. So now we need to solve for K. We do this by plugging the information from one trial into the rate law. Be sure that you don't mix and match information from different trials. So here I've picked trial 1 and I've plugged in my rate of 3, my concentration of 0.001 for H2, and 0.02 for F2. Notice I've accidentally written a 2 for the reaction order of F2. It should be a 1. So if we multiply 0.001 and 0.02, we get 0.00002 times K equals 3. Now all that's left to do is divide 3 by 0.00002. And when I do this, I get 1.5 times 10 to the 5th. It's very important to include units. For a second order reaction, the units are 1 over molarity second. And last but not least, the final step we need to do to actually write out the rate law is to put all of this together. You can see I've done that here for you, and the rate law is rate equals our concentration of H2 times our concentration of F2 times our K, which is 1.5 times 10 to the 5th. I hope you've enjoyed this video on rate laws. Be sure to like and subscribe. I would really appreciate it. Bye!